Here you go. And there is a link if you want to record it in Zoom. It's just already recording here, but if you want to share your screen, there is a link.
Link where?
In an issue. Let me send it to you.
HTML.
Yeah. Hey, are you coming? I'm sorry, you lost your slot.
Oh, really?
Sit down. You will do after Jeremiah. So, yeah, we can talk for a second. Here you go, and I need to pass you the link.
Let's see if I can full screen this.
If you can open it up, go to Node.js Summit.
The repo?
Yeah. Node.js / Summit. Yay. Issues and streams. Here we go. Yay.
How do I present from this thing?
Join. Just do not mute yourself. And just no record. I just recording. You just need to share.
Okay. Desktop.
Yeah, it's working.
Cool. Right. Second full screen. I don't think so. Whatever. All right. So since the last Collab Summit on streams, or the stream section in the last Collab Summit, I've made some progress. This is like an updated slide deck that includes a whole bunch of more stuff that wasn't included in the last one. Move this up. All right, so it's the not streams edition, it's the Bob edition. Cool. So I'm not sure how many people were here last time, but I think some people were not in Berlin, so I'm going to briefly go over some things about the project. So the project approach is a little bit different than things we've tried in the past with streams and adding on top of streams and kind of making this conglomerate thing. So the idea is to prototype something outside of core, which I've been doing for a while, and it's at a pretty good spot now. But then it's to prototype something that's compatible, that could be replaced underneath of the Streams 3 API. So we can replace the insides of it with that, and then really prove something out that if we want to actually then expose that to user land later on. So again, since there's some people here that weren't here last time, I'm going to go over why and goals briefly, and then I'm going to go over like the API as it's been in a little bit more detail than I got to last time. Talk about the current status. I have some modules and stuff, and then try to get a little bit of discussion going. Okay, so why would we want to reinvent streams? Obviously, or I hope obviously, the streams user experience is pretty bad with multicasting and event emitters, and there's any number of problems with that and error handling that we've been trying to fix for years, and it's not great. Also, the stream's performance is underwhelming because there's buffering everywhere in every step, among some other things. So the goals of this initiative, we're going to go over those. First, some terms that I'm going to use. Consumers or sinks, that's where the API end where data goes to. It goes to a sink or consumer. And then producer or source is where the API end where data comes from. So it comes from a source and it goes to a sink. And those together, I just kind of call the protocol. So there's a bunch of goals that we have for this that a couple of us laid out when this kind of began. I'm not going to go over all the goals. They're available in the repo that I will link to later. But the goals for the protocol itself are the most important. One goal is that pull-based Streams 3 are actually pull-based, but support push-based components from Streams 1. So we want them pull-based. We want them binary only. Mostly to simplify things, but also to make sure that that story is really good, and that's the story that we really care about in Node Core. We also want it to be stateless, or at least everything in the actual protocol to be stateless. At some point, you will need some state, like a file descriptor somewhere or that kind of thing. If you do transforms, you need a bit of state to tell it where you are. That's just how it goes. But the actual protocol itself can be stateless. So another thing is one-to-one, so no events or multicasting. You put one source together with one sink, and then transform is basically two of those on either end. Timing agnostic, so we don't make as many assumptions about timing with event emitters and next ticks and all the stuff that's in current node streams. Another thing is no buffering, at least in the protocol. Eventually, at some point, you will have to do buffering somewhere, usually at the endpoints, or if you're doing a transform, almost all transforms require some form of buffering. And also, we want inline errors and end, so we want errors to flow through the same data flow path as everything else, and end also to flow through that data flow path, because that just simplifies everything a whole bunch. So the current proposed API that I have, we'll go over this a bit. I think I was supposed to say something else there, I don't know. So here's what a sink looks like. I didn't really set stuff up too well at Berlin to show this kind of thing, but kind of have something now. So I have it sort of class-based because that's what made most sense to me. If we wanted to have more like Dominic Tar's pull streams or something, I'm sure we can, where it's a little bit more functional. There's options there. But this is what I've been prototyping with, and it seems to work pretty good and makes sense to me. So you have a constructor, you can send in some options, like maybe coding or like how much buffering you want to do for a transform or that kind of thing. Then we have this bind source thing, which is part of how you'll see how we set up these streams rather than doing the typical kind of pipe thing that we currently do. We use this bind source, and you'll see a bind sync later. And that does some simple stuff. I'll add some more in a second. And then next is where we would get data into the sink. I call it next. We could call it something else. But the main important parts are the kind of things it takes. So it takes a status you get back with, either continue, an error, end. You might get an error, and then you would get a buffer and the amount of bytes that were written. And so actually adding stuff in, it would basically look like this. When you do a bind source, then you also bind the sync back to you. So you've basically done a pull. And then during the next, you're going to do some stuff with the received data. And then eventually, if you want more data, you're going to pull again from the source. A source would look pretty similar. You have a bind sync. It's a little bit simpler because we don't need to bind from this end too. But then we have the pull where the sync would request data from us. And it uses either we get an error that's being propagated up, and we may get a buffer if the sync is allocating its own buffer. And then at some point, we're going to get some data in there, maybe from a network socket, maybe from a file, whichever. And then at some point, we're going to tell the sync that we have data and we're writing to it via next. Something like continue with no error. We have a buffer that we're giving back, maybe the same buffer, and a bunch of bytes that we've written. So yeah, and if you sort of combine these things, you get a pass-through or an identity transform, as what we G streams like to call them. And they are very simple in this model. This is an entirely functioning one because there's no buffering or anything in between. You could just implement this, and that would be good enough. And I mean, you could do something with this too, like say event. If you wanted an event whenever next is called, you could just emit an event there, and that would be it. All right. So composing these things, this is how I have the composition set up, or essentially how pull works. You make a source and a sink, and then you bind them together, which uses the methods that we just saw. And then you would also give a bind callback, which is basically like an end event, and that gets called when the stream is finished, or you get an error, or well, if you get an error, the stream is finished. But. And then if you wanted to use a transform in between, it would look very similar. You also make a transform, you bind the transform first, and then you bind the sync to the transform. and that will make everything flow from the source through the transform, through the sink. Okay, so this stuff is available at github.com/bishrop123/Bob. There is a bunch of reference material there. A lot of those are just like sort of simplified references so that I can fit them into slides. There's also a bunch of diagrams there that I now have that I will show you in a second, but if you'd like to go along or can't see this well enough, they're there. All right, so I have some diagrams for the flow that one of our designers kindly made us. Unfortunately, I don't have something like a laser pointer, I don't think, but that doesn't matter too much. So down at the far corner there, you have bind, that's where everything would set up. And then where you start is you start, and from the sink where after the bind is called, your data will propagate up. So you'll call the pull on the source, say this compression transform. That might do some things in between, but it will eventually do a pull to whatever your actual source is or another transform. In this case, it's the file source, so you wait on a file read, get data back, that would go through next back into the compression transform, and the compression transform might do stuff with it. Transforms may need more data, specifically for compression transforms, so it might actually go back and request more data before returning it further, but eventually it might do a couple loops there to say, okay, I have enough data to actually like emit a chunk that's compressed, and then it will pass it back down to the next of your, say, your network sync, and your network sync will write it out to a TCP write. And that will repeat as many times as necessary until you get an end that comes all the way back down. Does that kind of make sense, or does it not wildly not make sense to anyone? That would be useful to know. Okay. So that's like the basic thing. And you say, okay, what about errors? Well, this is what errors do. So say you have that going, and at some point there's an error in your compression transform. Well, we want to make sure we can close everything up. So what we're going to do is we're going to bubble it all the way up to the top. So we're going to send an error through pull each time. It goes through one here, but it could go through any number of them. And then on the way back down, starting with like the top source, essentially that doesn't implement a sync anymore, we're going to start closing it, and then say to next that we have an error, and stuff is going to close all the way down. And then eventually when we get to the bottom, we're going to give that error back to our bind callback. And so you can actually get the error and do something with it, but everything is already like all nice and closed up. Yeah, again, those diagrams are available on my repo, so you can take a look at them there, as well as all the other stuff. All right, so the current status, I have a bunch of modules. So we talked about at JSConf.eu that I should probably modularize some of these things into modules because it was a bit of a mess in that repo. That repo is now mostly just used for the reference material, essentially like the spec of it. So these are modules that I published, Bob status. There's an FS source and FS sync and a transform. Unfortunately, I haven't really cleaned up the socket enough to publish it, but there's a TCP socket and server that is functioning. There's a lot of C and C++ in it. Well, not that much C, but mostly C++. And I'm not the best programmer in C++, so it kind of leaks memory right now, but I know that people who are actually good at C++ can fix that kind of thing. So I haven't quite separated that out yet, but these things are working. They do all the things. Touch on performance again for people who weren't here last time. So the performance seems pretty good for any single stream. You get pretty good decreases in CPU time, even in situations where I'm doing like allocating way more buffers than I need to because the implementation is kind of just thrown together. The performance is about equal to Streams 3, and Streams 3 does like considerably better things supposedly with buffers, and yet I still get similar performance characteristics to it. And just a note, yeah, I mean these sort of things on CPU should correlate to throughput, but may not be exact. Okay.
What does the decrease
mean? Decrease in the amount of CPU time spent. Yeah. All right, so hopefully I can get some discussion. I have some open questions from myself if we don't have any questions, but hopefully people have some questions.
There is a mic. Oh, cool. Hey. This was all very exciting. It's getting more exciting every time. What's the roadmap for landing this?
Well, I think so. Right now, I've kind of gotten to like the point where I can't really prototype stuff more in userland, really. So the next steps really are to kind of decide like kind of how we like this and what we should do with it exactly.
So we should figure out what that means in terms of figure out how to work with something. Yeah, well,
from my point of view, it's we need to start looking into what this will mean for core, and maybe even spin up a repository and start tinkering with a fork or something.
Right. Yeah.
Up until we are comfortable in making the question with the rest of the collaborators, because this seems fantastic and these are really good ideas. So I hope, hopefully, if do you still? I have a question actually. Do you still have the flow on C++ on C++ level? Because I think
Yes.
yes.
The TCP sockets and servers are implemented down to libuv. Yes.
Yes.
We don't use any Node.js C++ streams.
What I was meaning is, when we were early sketching this, we had some sort of mechanism where if the two things were speaking this protocol, and we are good to detecting that, we could switch back to C++ for talking to each other, as avoiding the back and forth in userland, JavaScript land.
Well, since this is mostly sort of like class or object based, I don't think that should be too difficult. I know we're trying to do something currently. Yeah. I have a pass-through thing that kind of does this, but I think it can be done a little bit better than I'm currently sort of doing it.
Perfect. No, that was, so yes, the key thing there is opening up a repository, seeing if there is interest in stuff. That would be my proposal. At least opening an issue on admin or something.
Okay.
And creating a repo, and then a fork of Node.
Right.
And see if we can start thinking with that.
Well, the plan was to sort of bring these repos into Node.js once we were kind of happy with them. So if people think we're kind of happy with them, I can try to get that to actually happen now.
So to me, I don't think any of this alone should go into.
Sure. Okay.
Should go into Node. I think they can stay where they are. It's not something that we plan to maintain or keep forward in that form. At least I don't know what are your plans, but it's yeah.
I've been using this repo sort of like a spec repo almost. If we want that, then that may make sense. But
makes sense. So say we wanted to end this, what's the integration you're thinking in Node? Are we gonna extend the API service to be like create upstream or FS or TCP/FS? You know what I mean?
Absolutely not out of the gate. So the plan has always been, as I sort of mentioned earlier, to do it underneath the hood, so to expose Stream3 endpoints.
So they're not going to be user-facing?
No. I would like them to be user-facing at some point, but I would like to prove them out first so that we have a good base to then make that argument.
That's the end goal, right?
Yes.
Okay.
For me, anyways. I'll need some help from you and Mateus to actually make a Stream3 endpoint that works correctly.
I have a question. Those look like very exciting numbers. Has any of this been used in production with real work workloads where we could like actually test some of those assumptions?
No.
Okay, would that be a good next step?
It would be a good step to take at some point, but...
Are you looking for maybe people to use that stuff somewhere, or what's the state of readiness?
I mean, if you have something that can use a compression transform and a file write and read, if you'd like to just compress stuff, you could definitely use it for that. I wouldn't use the TCP socket until someone helps me with like the C++ side because it leaks.
in terms of bad and good cases, what are those cases? And is the bad case just temporary because the current implementation is something that we can improve?
That was taken from doing a zlib transform as well. It was, so those numbers are actually from quite a while ago, but that stuff hasn't changed exactly. When I did the socket profiling, which unfortunately I didn't get to be able to put together in this talk in time, the throughput was about the same for a single socket, like doing file transfers over it, but except that I'm like allocating buffers all over the place and not really like doing any buffer pooling at all. So like it's doing a lot more like mem copy and stuff, but it's pretty equivalent in performance, even despite that.
So let's move to maybe the next session, the next part.
Sure. I'm gonna very quickly just go over like my own open questions. It'll take just a second, and maybe people can think about them for the future. Okay, so like obviously, is this API likable? It's been mostly me working on this, so I don't really have a gauge of a room in my head. So I need to know that. Obviously, do we need a buffer pooling helper if we're not doing buffer pooling? We maybe like, again, performance is pretty comparable even if you're doing extra buffer allocations, but maybe we would want something like that. The API may be too pattern focused. I need a little bit of feedback on that. There's a question of how to enforce a single active request because we don't want people doing multiple pulls. That just gets messy. And then obviously where to start implementing this in core, and can we do libev having pull streams too? So things to think about.
Could the C++ implementation of this be libev pull stream?
Probably. Although in core, we might want to put like some sort of C++ wrapping on it to make it a little bit easier for people.
Yeah, but that was I don't know. This is my question. I don't know. Anna?
I'm not very good at making C APIs, so.
I came in late here and I missed most of the talk, but I've seen like prototypes of the software. If you're asking whether like libev full streams would be the entire implementation, we just have a small wrapper on that. No, because we have a lot of other types of streams. For example, like zlib or ss streams aren't libev streams.
Okay.
But I mean, like it could be pretty close to.
Here we go. So,
who's talking about?
It's Iris. I'm just gonna.
yeah, she's just standing nearby. Just
Provide
can you stop sharing your screen so I can share mine? And then. Yeah, I'm fancy. I got fancy with your toolkit. Yeah, here we go. And then I need just to share things. So, again, still me. So, we have talked in a couple of sessions before about what would be streams in core and some of the problem that those entails. And I've done some reasoning about the problem, okay? I don't pretend to have any good solution on this. I'm just pretending I just spent some time in thinking about how to solve the problem, okay? I don't want to enter the historical reason of this because those will get, a lot of people will get angry. So I'm not want to get into the historical reason. I'm just talking about the current situation. So what would readable streams are significantly different from our own implementation in a lot of different ways. And specifically, they are built around promises against event emitters. So this makes them more or less extremely different from our side. So we cannot really implement the two things on the same thing. I choose pipe 2 to explicitate this exact specific problem. This is a strong, bold statement that I have put together, and this is my current stance. So let's agree that we cannot replace Node.js streams. There's a typo there, so whatever. But replacing Node.js streams. So Node.js streams are something that we have to maintain forever, more or less. Express is based on them. All the FS tooling that we have around are based on them. The readable dash stream module, which is the more or less stable dash userland implementation of this, is the most downloaded module on NPM. All of this stuff, it's because, you know, the people are, depending on if I like them or not, I do not believe this is a fixable problem, okay? That's my stance. I think a lot of people, some other people that have put thought on this process, put some thoughts on this, have reached the same conclusion, but the current situation is we cannot get them out, at least at this point in time. In the future, who knows, maybe, but not in a foreseeable 1 to 3 year time frame. So that's not what I want to talk about, okay? And sorry, if somebody believes this, please, we can, is there somebody that does not think this is, does not agree on this, because this is more or less what all this talks about. So why we want WhatWG streams in core? Why? Well, they're part of the web standard, and it's supported by fetch. They are needed by the fetch specification. And overall, it will make things a little bit more consistent with the browser ecosystem. And there are a lot of possible future usage, for example, on web workers, WebUSB, WebAssembly. All those sort of things have this type of, as this requirement. So what do we want to do? Are we not implementing those packs because it is missing? Should we add them to core? How do we backport the stuff? Because if we add them to core now, what about Node.js 6 that's still LTS? You know, we have ours is a moving target while we have major versions, while the browsers, what they implement is kind of, you know, additive only. We have, you know, all our LTS process to think about. We are not a browser. Problems of adding them to core. First of all, they are globals. And adding globals is, adding a new global is a Semver major because it will break people. So that's the thing. They have the same name of all the stuff that we have in require stream, exact same names, which adds confusion to confusion. We already have a massive amount of confusions in streams. Stream 1, stream 2, stream 3, whatever, what's destroy. All of this is confusing. Hey, it's a problem. And how do we, adding them to core, again, as I said, is maybe a Semver major addition. And the overall compatibility with other core API is messy. Would be very messy, because how do you fit this new thing that you add as globals into the rest of the Node API? Note that we have choose 2 methods, actually 3. 3 methods in core, 3 functions in core that takes a node stream as an input. Pipeline, and finished. Those are the only 3 methods that receive a stream as input. All our code does, it creates streams. It doesn't consume these things most of the time. So all of that, it's the code of our users that consume those things. So we are not in control of them. There's been a PR open by Gus earlier that added this thing added WhatWG streams into core, and that's a URL you might be interested. The major problem about that implementation for me is this block of code. This block of code, as you can see, it adds a required standard stream to Node Core. I hope you read this. It's very tiny. The problem with this is it does double buffering. Double buffering means that the performance of our already slow node streams implementation will be reduced again. So basically, you are creating another thing that will slow things down. So I'm not, do we want our runtime to improve the performance, or we want our runtime to slow this performance, okay? I don't know. So that is the major, that's why I am a little bit, this is one of the reasons I'm a little bit skeptical in adding a wrapper, okay? We're adding a wrapper between the user and the data, and this is a little bit problematic. For me, double buffering is a no-go. I'm not interested in double buffering anything, introducing double buffering for things. Yes. Yes. Double buffering as a known goal. We have a significant amount of double and triple buffering already in Node Core, which is bad, between bad and extremely bad. And removing all of that should be a goal, not adding more. So that's kind of the thing. And then we have async iterators. I don't know if you knew about async iterators in Node 10. In Node 10, we ship async iterator, which is just fantastic. And you can write this type of code. So you can use 4 awaits to iterate on chunks of a string. Note that WhatWG stream are specifying kind of the same behavior. So this code above should work the same on both. It's good, it's bad, it's a route that we might want to pursue. It's just basic Node.js. It's just basically JavaScript code there. Okay? Going forward, however, this type of syntax has a problem, okay? How do we nest things? How do we create a pipeline? Okay, we have seen one of the key concepts of streams are we have a readable, any number of transforms, and writable. It's a long pipeline, can be as long as we want. How do we create a pipeline with this? How do we create a data processing pipeline just using basic async iterators? How do we even write stuff? Like, we have these accumulate. How do we even write stuff? Like, all of this is not done by the spec, and there is no common pattern to do this type of operation, which I call it the pipeline problem of async iterators. I wrote this snippet of code, which I probably don't like too much. It's a little bit too complex and too convoluted, but this is more or less what it does. We take, if you want to pipe 2 things together, this is a pipe implemented using async iterators, which takes an origin and a destination and builds this bright abstraction, which is just a function that returns a promise so that I can return to, so that basically I can for await and then pass it down. And then we need to, promisify that we have finished we need to await the fact that we have finished our stream. And this is some very good things, which is very JavaScript idiomatic code. Like it's very, easy to read to some extent. So I like this. The bad stuff is this piece of code, which is unreadable from that far, kind of on purpose. It's really it's somewhat. There's a mistake, but forget the first line. But it's a little bit of complex code because of our error models. And because the fact we want to support buffering on the other side. So basically we are in the async iterator model and in the promise model, we are doing the way errors are handled. They are handled when somebody looks for them. While in our event emitter model, error are kind of needs to be emitted and handled at that specific time. And this creates a little bit of a mismatch. And this type of code does it so that we have an on-error handler there that waits for an error to happen, more or less, and it will error on next write. And that's what it is. And the code can be, this code is bugged, by the way. It's not complete, but it's a short version of what this is. Okay, so I just wanted to put this in front of people because this is stuff that we might want to work with and work on this as an interoperability path for getting something that was similar. So letting users write the same code, either if they are using what-would-you stream or readable stream, just by using the things that we have in common, that is pure JavaScript, which would be, to me, would be should be the goal. Like I prefer this to all those complex piping elements for high-level operations. Low-level operations, probably we are using the wrong abstraction again. So there is this type of mismatch. So I'm going to wrap up. So the path forward is take async iterators out of experimental notation 11 and solve the pipeline problem, maybe with an utility in core or something like that. Also, I want to propose to write a new ecosystem module and maintain it as part of the node organization called what2g-stream, which is Samver, and it's in the ecosystem, and it supports for all node versions. So it's basically our official compatibility layer between the two, which currently does not exist. It is not really maintained by us. There is some stuff over the internet, but it's not easy. And the question is, how do you make the two streams compatible? Well, you can use something like the pipeline operator that we already introduced in core. So that, the only point where we want to do things is we want to pipeline. We want to pipe two type of streams together. Because if I need to extract code, if I need to write code and just extract a chunk, I can use async iterators, right? So the only thing that is left is avoiding double buffering while piping, we can write a utility that can take either a node stream or a what-would-you stream and stick them together. Okay, it will be hard and messy and super ugly, but we can make this happen. And it's probably the best way forward. And you can even do you can get as complex and things that you want, but the fundamental primitives between the two streams are very similar, so you can match them. It's just the API is completely totally different from what the board. It's probably 5 minutes for questions, and then you have 10 minutes for that part. Are there any questions about what all of the rubbish that I just said? Where is the mic? Do you have the mic? Are there any questions? Somebody.
Do you mind if I just set my computer?
Yes, set up your computer.
I guess I'm solely ignorant about what WebG streams or however you pronounce it. So I represent the ignorant users or non-users of those streams. What is what are the benefits from users of the current form of streams to use those new streams or those different streams?
Zero, from my point of view. The main benefit is web compatibility. So you can use the same code on the server and on the client. That's the only one.
Okay, cool.
Like I do not see any other real benefits.
Supporting web APIs that use it.
So support web APIs is the benefit.
So what APIs are using that?
Fetch.
And then so why would I want to use Fetch? I mean, it's a genuine question. I'm not
Because HTTP client request is not so good.
HTTP client request is not so good, and that works extremely well in the browser. And the Node fetch on Node has a different API from what fetch is on the browser, and it makes writing isomorphic code extremely hard. And it's this is a huge pain that is blocking the community to go forward. So that's why I slightly switched my personal opinion on what would use streams over the last year, talking with people. So
it's really an interoperability.
It's really an interoperability concern. I would say it's 90% an interoperability concern. What would use streams have a clear benefit of being specified, which is, I think, is a clear benefit, so that they didn't evolve organically, and they learn from some of our errors on Node streams. So they are kind of better in similar ways, but we cannot really, if we don't want to gut and kill Node.js, we cannot really remove Node streams. So that's
a great answer.
You're still in some time.
No, I just. Whoa.
Oh, okay.
I'm just gonna steal your computer.
Yeah, steal my computer. It's fine. It's your computer. My computer is your computer. Yeah. No, it's the problem is that you will always do it. Unless you pipe the two together by writing some code that just does not introduce that double buffering, but the moment you introduce a wrapper entity between the two, you will have to talk about it.
But how do I make the thing go to there?
You just plug it.
I did. It's all in Italian. I don't know. It's. Well, that wasn't in Italian. That one.
That was not in Italian.
Awesome.
Okay. Let me. It's this one, right?
Yeah, I just like that.
Here we go. I need to screen share again. Here we go.
Awesome. Thank you. So just a little hastily prepared presentation about error handling. You should do error handling very hastily. There's some overlap here with some of the things we talked about in Berlin, if you were there 6 months ago. But basically, we're working on improving streams error handling. If you've ever done anything with streams, you might know that this is probably the trickiest part, especially if you implement your own streams. So some things I don't have in the slides. We recently added the pipeline operator to core, which basically means if you're piping streams together, you should be using that one for error handling. It's really, really good at that. But I'm not going to talk in details on that. We have really good docs on it now. So a couple of things. If you ever implemented your own streams, in later versions of Node and in readable stream, we actually standardized destroy. This is a while ago, years ago actually, but we very recently made the guarantees that destroy make a lot stricter. So it's actually very vague what it actually did before, which you might not be familiar with, but it had a lot of issues. So basically, if you ever implemented the _write method, which is the method you implement when you want to make a writable stream yourself, there was actually no guarantees before that the stream would stop calling that after destroying it, which is kind of interesting. So we fixed that one.
Is this landed yet?
This landed in 10, and it's in readable stream if you want to use all the ones. So yeah, when things haven't landed, I'll make a notice. So that's really important, really nice. Same with _read and _flush or final or whatever you have. All the underscore methods, we have good test coverage for that and stuff like that. Also, we recently landed that when you call destroy, it will always emit the close event. I'm not sure if we landed it at the time of the last Collab summit, but it's in there now. So that basically means that if you do call destroy, you can always listen for close, and that's going to be the last event you'll ever see on the stream. So it's not going to emit any data after close. So really good guarantees there, which makes the state machine a lot easier to deal with. It's very nice. So this is a pattern I see a lot in user code and also in core. When people do error handling with streams, they tend to just treat it as an event emitter and emit error. We need to really stop doing that because it's terrible. Because basically the stream is a huge state machine, and the state machine doesn't get shut down when you just emit an error, it just emits an error. So basically, by doing these things, we cannot shut down the read loop or the write loop or whatever it is we do, and that creates a ton of memory problems in practice. So we really need to stop doing this everywhere, both in core but also in userland, and just always do this call stream.destroy and make that handle the shutdown of the state machine. So I've been working on a PR in core for that. That's still in progress because I don't have infinite time in my world, but it's gonna land hopefully soon. I just know Matteo is pinging me every day about that. So a couple upcoming things are in progress around that for node core streams. Basically, we're working on now, this is the PR that's in progress. So we have the destroy method, but the only way the destroy method gets called right now is if somebody calls it, which is pretty cool, but it's also kind of sad because it would be nice if you just had one way where you would do stream teardown. So when I look at user code, I see a lot of people listening for end or finish and then shutting it down there, which is a bad idea because they might never be called. So what we're changing is that streams will always end their life cycle with calling .destroy internally. So life cycle end means that if it's a readable stream, once the end event has emitted, fully flushed, or if it's a writable stream, once the finish event has emitted and the stream is fully written, and if it's a duplex, both. Once that happens, we'll call destroy internally, which means that your underscore destroy method would always be called on any life cycle unless you just throw away the stream. So this is really makes a lot of things a lot easier. So that's very exciting. The first version that will land of this, which is the first PR, is gonna make this opt-in. We're calling it auto destroy. So you will create your streams with an auto destroy true flag. The reason for this is that then we can land this as a sender major. Minor. The other one, the good one. Then we can land it as a minor, so we can get it out really fast. And also we tried to make it default first, and it broke basically all the tests. That's kind of sad. So this will hopefully land pretty soon once I get it landed. And then future version of this, the big picture, we'll do this per default because this is just in general a better idea. But this is not going to land anytime soon because it's a similar major change. So this would probably, if we're lucky, get out in 11, but most likely in like 12. If ever. This is more controversial, but this is like well personalized. I noticed this the other day. So just a call to action. There's actually a ton of documentation missing on all this error handling. So none of the destroyed flags are documented anywhere. That destroyed, which is a super important flag. It's a Boolean whether or not the stream was destroyed. So if anybody's interested in doing some easy help getting all the public properties documented for error handling would be very helpful. And that's my final slide. I need a question slide. But does anybody have any questions about error handling?
Yes.
So can we detect when someone commits an error when we use an error?
Yeah, so that's a good point. So to get rid of the where was it? There you go. These are actually detectable because you should never do this unless the .destroyed flag has been set. So we could at some point once the new things start landing, we could actually deprecate this with a deprecation warning. Which I would be very. Yeah, but that's. More, I would rather for the deprecation. But anyways, yes, it's detectable.
Yeah. Any more questions? I would just note that we need more docs for streams in general. And if there are any volunteers, anybody who wants to learn more about streams, or anybody who wants to help with what to do streams, or anybody who, please reach out, and we can even run weekly or monthly meetings. At this point in time, we are really low on forces, I would like to say. There's a lot of people in the room,
So I hope that somebody wants to. Somebody, a volunteer. I love volunteers.
Get the name.
Get the name. Yeah. Get your name now, and you get a job.
On that note, we might want to think about starting up our meetings again.
Yeah, that's absolutely. So those things don't start for a lot of reasons, but we need to revamp that. So, is there any questions or points that even curiosity? No? Very good. Okay. Hopefully it was helpful for everybody. And thank you for joining.
Awesome.
Thank you. Organizational agenda thing, we're meeting back here at 4 for the final closing part. So that, you know, stay around, do not leave. Secret sign, yes, absolutely. For sure. For sure. Right, there we go.